Hello and welcome back. Today we're going to be talking about the acceleration due to gravity and free fall. So, let's first talk about Earth. Us humans, we live on Earth, right? And you've probably heard of gravity. Gravity is that wonderful, fantastical force that keeps us locked onto the Earth's surface. If we jump, we're going to come right back down because of gravity. So, let's talk about some math we can do with gravity. If you're in an AP class, AP Physics 1, 2, C, D, whatever AP classes are out there nowadays, you've probably seen the big three kinematics equations. V equals V naught plus AT, delta X equals V naught T plus 1/2 AT squared, and V squared equals V naught squared plus 2a delta x. Let's call this equations 1, 2, and 3. And we're going to be using these quite a lot. They may look a little different if you have an equation sheet given to you by a teacher, but this is the equations we're going to use for basically all kinematics, and they're all you're ever going to need. There are some resources out there that have 5 equations, but they're really just derivations from these 3. So they're not super needed. You can do most, if not all, kinematics problems if you're in a physics class or you're just doing it for fun using these wonderful big 3 equations. You're going to learn to love these. These are something amazing. These are incredible little creatures. So, I talked about gravity. I talked about how the Earth pulls us in with that gravitational force. And for kinematics, which is what we're doing right now, we can assume that all situations are happening near the surface of the Earth. So, we're on the floor. That's near the surface of the Earth. Let's say we're on a big old cliff. That's still considered close to the surface of the Earth. Now, why is that important? Why is it important that all of our kinematics problems take place near the surface of the Earth? Well, that's important because of this wonderful little value. G. Wonderful G. G is 9.81 meters per second squared. What is this number? What does it mean? What does it do for us? Well, G is the acceleration due to gravity. Acceleration due to gravity near the Earth's surface. Okay, that's all well and good, but why do I care? Why do I need this G character? Well, let's take a look at our big 3. There's acceleration in this one, acceleration in that one, acceleration in that one. Acceleration seems kind of important in kinematics, huh? Now, let's say we take equation 2, for instance. Delta x equals v naught t plus 1/2 at squared. And I'm going to do some magic. I'm going to make this x disappear. But instead, I'm going to replace it with y. Y as in the vertical direction, up and down. And you can do that for all kinematics equations. You can replace x with y or z or whatever you want. But in our case, x is horizontal, y is vertical. So let's say we have a ball, right? Ball is about 10 meters up in the air. This is the surface of the Earth. What's the acceleration? Well, I think you guessed it. G. This wonderful, wonderful value. Man, I love G. G is extremely helpful. You're going to learn to love G as well. Now let's talk about directions for a little bit. We'll go back to that same example. There's a ball 10 meters up in the air. Let's say it was dropped, and so it starts with a VO or V naught of 0 meters per second. It's at rest right up there, and then it goes down. Why is it going down? Well, gravity, of course. So which way is the velocity vector pointing? Well, it'd be pointing down, wouldn't it? It's going down. That's the direction it's going. Now, acceleration is also a vector. So which way would the acceleration vector be pointing? Well, that's right. Down again. Because think about it. Our acceleration is going to be accelerating or speeding up that ball as it goes down. If it starts at rest and it lands at, let's say, 10 meters per second, that's our final velocity, it must have accelerated. It must have sped up, but it sped up downward. So our acceleration vector also has to point downward if it's speeding up. And our acceleration vector, if we keep the surface down here, no matter if our ball is going upward, if our ball is going this way, if our ball is going that way, our acceleration vector is always going to point down for gravity. And that's because that's the only direction gravity pulls. There's no reason for gravity to be pushing you sideways, right? Gravity is a downward force. It's a downward acceleration vector. Now, hold on. Don't we usually say down is negative? Well, yes, you're right. You could say g equals negative 9.81 meters per second. But I will say this. In future problems, in future videos, sometimes if all of the motion is going downward, it's easier to change down into the positive direction. Now, that might not make a ton of sense right off the bat, but you'll get used to it, I promise. And what I mean by changing the downward direction to be positive, you actually change the signs. So our velocity here, if we count that down is the positive direction, our velocity is actually positive, even though it looks like it's going down, because we defined down as positive. Our acceleration is positive. It would be plus 9.81. But of course, you can only do that if you change everything. Everything has to be pointing down to be positive. If you have something going up, that's now negative. So you have to be really careful when and when you cannot change 9.81 to be negative or positive. You know, that sounds like kind of a lot of work, but trust me, it does actually make problems easier if you do it correctly. Now, to end this video, let's do a very simple example. This example we call free fall. Why do we call it free fall? Because the object that we're going to model is just falling. And it's not going right, it's not going left. The only thing working on the object is gravity. Free fall. Let's say this is the surface of the Earth, and we have a big old boulder right there. And let's say that boulder is 50 meters in the air. Let's also say this boulder is 100 kilograms. It's a big old thing. Big old boulder. So how long is it going to take for this boulder to reach the ground? Well, let's go to our big three. What information do we have? We don't have final velocity, so I think we're going to rule out number 1 and number 3. So let's use equation 2. Delta x equals v naught t plus 1/2 at squared. Now, you may have noticed, I didn't say there was an initial velocity. All I said was this boulder is in the air. So if that happens, you can assume v naught to be 0. Up here, it is just standing still. So this entire variable can go away. And like I said earlier, we can change delta x to delta y. So we're going to do that. Delta y equals 1/2 at squared. So what's delta y? Well, you may have the instinct to say our final position would be 0 meters, and our initial position would be 50 meters. But I'm gonna do some finagling here. I'm gonna do something else. Like I mentioned earlier, you can change the positive direction to be pointing downward. So I'm gonna do that. And why am I doing this? Because all of our motion is going down. So it just makes things a little easier. So down is now positive. So how we're going to model this is now it starts at 0 meters and ends at 50 meters. So that means our delta y is going to be a final position of 50 meters minus 0 meters. And hey, look at that. We have a positive value for delta y. Things are looking a little simpler now. 1/2 stays the same. Now, acceleration. What's acceleration? Well, what's working on this boulder? Gravity. That's all. That's the only thing working on this boulder. So, our acceleration is going to be 9.81 meters per second squared, or g. Now notice how I made it positive, not negative. That's because it's accelerating downward, and we defined downward as positive. So 9.81 meters per second times t squared. And t is what we're looking for. So let's take out our handy dandy calculator. 50 divided by 1/2 times 9.8, 1 is 10.194 equals t squared. Square root that, and you get t equals 3.193 seconds. So this boulder takes 3.193 seconds to reach the ground. And that was your introduction to the acceleration due to gravity and free fall. Hope you learned something, and happy learning.